Okay, so the setup is you are at the point 0, 0, 1, right? And there are Vashta Nerada, which are piranhas of the air, all around you. You don't want to be eaten by the Vashta Nerada. It's not good. Okay? Okay, so, no, what the hell? I'm making this a quiz. So, not right now, but your quiz for Friday. You guys got this? Quiz Friday. Go watch The Silent Library. It's a Doctor Who episode.
Do you know which season or anything like that?
No.
Do you know which doctor it is?
Yes.
Which one? Because that'll give us.
David Tennant.
Okay, so it's
David Tennant, I think.
okay.
Donna's the companion.
Yeah.
Okay.
I've seen through season 2, so I know it's after that.
Yeah, it's David Tennant.
How do you spell the last name?
It's the episode where River Song comes into the series. What?
How do you spell the last name?
What last name?
I can't tell if you're saying Tennant or Tennant.
It doesn't matter.
If you don't know,
If you don't know,
It's a Doctor Who episode. The
Season 4,
The Wiki.
thank you.
Silence in the Library.
Okay, go watch that. There will be a quiz. Okay. So we have this function, v of x, y, and z is e to the 2x minus 3y plus z squared. And we're standing somewhere and we're asking, what is the directional derivative in the direction of the point? This is a point 3, 2, 1. Okay? Cool? So you're standing at this point and you're looking that way. And you're wondering, is it a good idea to go that way? Basically. Cool? So, what do you need for a directional derivative?
The point you're heading towards and the point you're starting at.
Okay, I got those.
You need the difference.
The difference
between
between
them.
them.
Okay, so I need the vector that points that way, right? So what's the vector that points that way?
3, 2, 1.
3, 2,
0.
0. You guys see that? That's literally this stuff minus that stuff, right? Okay, so I got the vector 3, 2, 0. That's a vector in the direction I want to go. What else do I need? Yeah, I need the gradient. So what's the gradient of v?
Yeah, ends up being, I'll just read it.
Partial x, partial y, partial z, right?
Yeah.
So that would be e to the 2x minus 3y times 2.
Yep. Then e to the 2x minus 3y times a negative 3.
Which I would like to point out was the biggest sad face ever on this, guys. There were a number of minus signs that were lost in the making of this gradient vector.
And 2z.
And 2z. Also, some of you made me sad when you forgot the chain rule. Please don't make me sad. Okay, so I got the gradient of v. What else do I need? I need a unit vector pointing in the direction. So not 3, 2, 0, but how long is 3, 2, 0? Square root of 13. It's okay, I got one of those wrong on mine too, and I didn't notice until I had graded 4 of your guys' tests. I was like, oh, 9 plus 4 plus 1 is 14. Luckily, in this case, it doesn't have the 1. So it's 13. Okay, so now I know how long that is. What else do I need?
The angle.
No. Don't make an angle. It's too much trouble. Evaluate what? gradient where?
At the point 3, 2, 1. 3, 2, 0.
Where are you?
Oh.
You're at 0, 0, 1, right? So where does the derivative matter? Where you're standing, right? If you're looking for a directional derivative, you're wondering about the slope from where you are. So you need to take the gradient of v and you need to evaluate it at 0, 0, 1. And so you get out of that 2, negative 3, and 2. Okay, and then what do you do with that? So that's like the total derivative, right? But then which way are you going? You're going towards this, right? So you need to take that, good, and dot it with 3, 2, 0.
Over 13.
Yeah, and then you need to divide the whole thing by the square root of 13. I would recommend, by the way, and I noticed a lot of you guys, when you unitize stuff, you do that division in there, and you get these kind of messy square roots on the bottom, and then when you dot product, there are lots of those.
Wait, is that square root of 13 over both sides, or just over the single one?
It doesn't matter.
Okay.
Right? Those are the same thing mathematically.
Okay, I just want to make
You
sure
guys are all
we
with
do the
me?
dot product first. That's all I wanted to make sure of.
Personally, I would do the dot product with the integers, because those are easier, and then divide the whole mess by the square root of 13. Instead of dividing this 3, 2, 0 by the square root of 13 and then doing the dot product and having lots of square root of 13s. Okay,
So that doesn't matter now.
guys cool? So when you do this, you get what?
6 minus 6 plus 0.
Oh, great. So I don't have to divide by the square root of 13 at all, right? Because I got 0 on the top. Perfect. Nothing. Split square root of 13 ways is still nothing. You guys cool with that? Okay, so once I got nothing, what does that mean?
There's no change.
There's no change in the amount of Vashta Neradas.
Yeah, so the amount of Vashta Nerada is constant in that direction. So in the direction of the point 3, 2, 1. Well, what? What if I lied a little bit?
At this instance, is that?
Yeah, instantaneously, right? It's not necessarily that this won't change later, but initially at least, right? In that first instant of movement, there's no change. You guys see that? It's not to say you're not fleeing into a hell swarm of Vashta Nerada, right? It's just that right away you're not. You guys see that? Oops. You guys all good with this? Okay, so then, better question. What is the best direction in which to flee?
To the door.
I was going to say, you've got a lot of
Okay,
answers
the
for this.
library's bigger than that. Watch the episode.
Opposite the gradient, like the opposite direction of the gradient.
Yeah, good. You want to go in the anti-gradient direction, right? Because the gradient points to where this is the biggest increase, right? So if you flee in the 2, negative 3, 2 direction, you are totally screwed. You would like to run in the opposite of that. So literally do that, right? So the direction in which you should flee in the, what's the opposite of that?
Negative gradient.
Negative 2, 3, negative 2 direction. Does it matter that that's not a unit vector? No.
You just care about direction.
Yeah, anything parallel to that would be just fine. So if you unitize this, pat on the back.
Just the instantaneous rate of change, and then every time you click on this thing that you change, you want to like reposition your vector.
Yeah, exactly. Right? So you do this like one step, and then you need to calculate the gradient again and adjust your course. You guys see that? But that's what water does. When you drop water onto a surface, it flows down that kind of gradient, 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 gradient thing.
Yeah.
Well, anti-gradient, right? It's flowing down. You guys see that? So really what you should do is you should flee in this direction for a little while and then evaluate the gradient again and then flee in that direction for a little while. And that will eventually probably work as long as your steps are pretty small. Cool?
Shuffle away from
I mean, there's definitely no getting away from the piranha spear though. So you're hosed. This will just keep you alive slightly longer. Cool? Questions, Steels?